Hey guys, Google just released their A2A protocol, which allows you to connect your AI agents to other agents created by other developers and companies, no matter which framework they're using underneath the hood. So if you want your AI agents to be more powerful and leverage the capabilities of other AI agents, you're definitely going to want to watch this whole video all the way through so you can learn how to master this new A2A technology. And to help you guys understand and to start using the A2A protocol, I've broken down the rest of this video into 3 phases. In phase 1, we're going to cover the basics of the A2A protocol, where we're going to cover why do we need it, what are the core concepts, and how does everything connect. Then in part 2, we're going to get our hands dirty with some code and actually dive into a code example where you're going to see how we can use the A2A protocol in a simple workflow where we have a client actually interface with an agent using the A2A protocol so you can see everything in action. Then finally, in phase 3, we're going to dive into the coolest example that I've seen on YouTube when it comes to A2A protocol, where we're going to set up a multi-agent system that's using the A2A protocol to connect everything together. More specifically, you're going to see how we can set up an ADK agent to talk to a CrewAI agent, a LangGraph agent, and another ADK agent, all using the A2A protocol. I've never seen anything else like this on YouTube, so I have a special treat for you guys when it comes to seeing this example in action, and I cannot wait for you guys to see how cool it is to make it to where agents can easily talk to each other using completely different frameworks. And to make things even easier for you guys, I've broken up the rest of this video with a bunch of timestamps so you can treat this video as like it's a reference guide. So as you're off on your own, building out your own CrewAI agents that are using the A2A protocol, LangGraph agents using the A2A protocol, you can always just hop to the different timestamps in this video to see exactly how I built everything so you can jumpstart your journey when using the A2A protocol. I've basically tried to make this the one video that you need to watch to master A2A so you can easily start to integrate your agents and have them collaborate with other agents no matter what framework they're using, all using the A2A protocol. And because you guys are awesome, I'm going to be giving away all the different code examples you're going to see right here in today's video completely for free. Just click that first link in the description below so you can download everything. And with all that out of the way, let's go ahead and dive into phase 1 so we can master the core concepts of A2A and see how everything works. Oh, and real quick, if you're looking for help on your AI projects, you'll definitely want to check out the free Skool Community I've created for you guys. We have over 7,000 members. We have free weekly coaching calls and a bunch of extra resources you get completely for free. So definitely recommend checking out the link in the description below. And if you're looking to get help from me on bringing your AI projects to life, you'll definitely want to check the other link in the description to where you can hire me so I can help build your AI projects for you. But enough of that, back to the video. So it's time to dive into phase number 1, where we're going to understand the core concepts of agent-to-agent protocol, why it's so important, and how everything works together to make our life easier as AI developers. And before we dive into actually looking at examples and workflows, I do just want to mention the core principle of A2A is that it standardizes the way agents communicate. So as we're looking at these examples, just continually think, oh, all we're trying to do is just standardize the way agents communicate with one another. So to help really drive this home, what I want to do first is dive into an example of what agent-to-agent communication looks like without the A2A protocol. So you can see a few major holes and problems that this framework and protocol is going to solve for us. Okay, so let's imagine we have a personal assistant agent and we're going on a business trip where we want to book a hotel from a hotel agent and rent a car from a car rental agent. Well, in the current paradigm, what we have to do is say, okay, I have a personal assistant agent and I need some way for my agent to talk to this agent and this agent. And as you start to think through this problem, a few questions come up. First, you have to say, hey, what can this agent do? Then you have to figure out like, well, what information do I send it? Is there a certain type of information I can send? Is it audio, text? Is it expecting it in a certain format? And then once the agent is done, well, what kind of response can I get back? Is it going to be a JSON? Is it going to be just raw text? Is it going to be a job and I'm going to get back like a task ID and I should check back in 10 minutes later? Like, what can I expect to do? And for each agent that we work with, we have to answer this question over and over and over again. And we have to build some tools and wrappers around each other agent we're trying to communicate with. And as you can see, like this is just a lot of redundant work that we have to do over and over and over again as we want to work with more and more agents. And it puts a lot of work on us. So what A2A tries to solve and does a really good job of is standardizing the way communication happens between agents so that, hey, going forward, I know whenever I want to work with this hotel agent, I have to do very minimal work and everything is just standardized. I can send messages, I can get stuff back. I know exactly what these agents do. And that's exactly what I want to show you now that we can dive into what everything looks like with A2A. And this is where we're going to dive into some core concepts. All right, so let's actually start back and replay the entire situation over again, but now with A2A. So now what we're going to do when we create our personal assistant, what we're going to do is give our agents some sub agents. But more importantly, these sub agents are actually going to be remote agents. So as you can see, I'm now saying, hey, I have a hotel agent. This hotel agent is using the A2A protocol and it is on this port over here. And the car rental agent is, once again, another remote agent on 103. Well, at this point, you might be asking yourself like, okay, well, all we've done is given our agents some URLs. How the heck does our agent know what these two agents can do? Well, this brings us to one of the first core concepts of working with the Agent2Agent protocol, which is figuring out what can these agents do. And it all comes down to a concept called the agent card. The agent card can be thought of as just like a business card to where if you were to, example, meet a plumber, the plumber would be like, hey, I'm Bob's Plumbing. Here are the 5 major things I can help do in your home. And that's exactly what the agent card does. So let me just show you a quick example of the agent card in action. So when we dive into the code later on, you already have a good idea of what it can do. But yeah, like I said, at the end of the day, it's mostly like a business card where it's going to say the name of the agent. It's going to say the inputs and outputs it expects, like text, audio. It's also going to say all the different skills that this agent can perform, such as like fixing a sink, you know, adding some more pipes to your house, like all the different skills this agent can do, it's going to put right here. And just to give you a more concrete example, looking at our hotel agent, what you'll notice is, once again, our name, we're just going to have a Hampton hotel agent. Then when it comes to the description, this is usually just the high level overall description of the agent, such as like, hey, I'm just your personal concierge to help you with booking and managing your reservations. Nothing too specific, just high level. I help you with your bookings. From there, we're going to recap all the like URL, the inputs and outputs. And most importantly, at the very end, you're going to put all the different skills that this agent has. So this is where you're going to put in like, oh, more specifically, I can help you book a room. I can help you change your reservation. I can help you find available dates. So all the different features that you can actually do and help answer a request on, that's what you're going to put in the agent skills down here. And this is what really helps our personal agent when it's talking to the hotel agent to fully understand like, oh, I know what you do and exactly what you can do. So now I know how to communicate and send information over to you whenever I have questions. And, you know, at the end, this is probably the coolest part is you can actually give a few different example queries just so you can be like, oh, if someone wants to book a room for this weekend, oh, that means we probably need to use this agent skill. Or, oh, are there any king suites available on this, you know, during these dates? Oh, once again, we probably need to use this room booking skill. So this is agent cards at a high level view. Don't worry, you're going to see it more as we dive into the code later on. All right, so back to our example. So far, we've understood A2A can help us standardize what agents can do. So whenever our personal assistant agent is trying to figure out, hey, I want to book a hotel, it's going to look at both of the agents it's connected to, see what they can do, and then know to direct all booking questions to this agent, hotel booking, and all car rental questions to this agent. So that is option number 1. So now that we know what agents can do, we now have to actually figure out the next part of the protocol, which is like, hey, how does this agent right here actually send information over to these agents? What are we doing? So this is where, you know, A2A adds in some more functionality for us, which is standardizing communication between agents. So here's what it does. When using the A2A protocol, what it does is it allows you to actually send messages over HTTP or HTTPS, and everything is done in messages. So if you've used OpenAI or pretty much any AI framework up to this point, there's always a core concept of messages, where messages usually have a role and they have some piece of text. And if you think about it, agents, they take in text or audio, they take action, and then they send back text. And that's exactly what A2A has standardized. So let me actually show you what a message looks like so you can see exactly what's getting sent from our client agent, our personal assistant agent, over to this hotel and car rental agent. So you can see, oh, that is pretty straightforward, and I understand what messages are getting sent from us to our remote agents. So here's what it looks like in a nutshell. This is an example of a client agent where we're saying, hey, I'm working on behalf of the user, and what I need help with is I want to book a hotel. So this part of the message is where it actually contains the raw text. So you can say, hey, I am type text and here is my text. And this is where we would put in the like, hey, I'd like to see if there is a hotel for July 1st through July 4th. And then from there, there's a bunch of unique identifiers to help our basically refer to these different pieces of information later on, such as like, hey, this is the unique message ID. I belong to this task, which we'll talk more about in a second, and context ID. Because when working with agents, there's usually some sort of context and state. So you can be like, oh, when I was sending this message, I was working with this context, and you can usually tie things back together. So it's really just to help you with state management later on. Okay, so now once we have this message and we send it, what's going to happen is the agent, the one that we're working with, so the hotel agent, is usually going to send us back two different types of information. So it's going to send back this send message response success if everything works perfectly. And if everything works perfectly, it can do one of two things. First, if everything works great, it can either send a message. Oops, sorry about that. Let's go back really fast. It can either send a message or it can send a task. So a message is exactly what you would expect. Like if you're chatting with any regular LLM, it's going to go, oh, hey, I'm sending you back an agent response. Oh, and it looks like the hotel is available during those dates. It's going to cost this much money. Would you like to go ahead and book it? And then it's going to refer back with some new message IDs, the same task and context ID. So that's if it's a very quick response, it's just going to shoot back a very quick message. Next, if it's a long running job, so let's imagine you're working with CrewAI, and what this agent was going to do is it was actually a full-blown weekly planner agent that goes off and does so much stuff. It researches best rates. It then plans the whole trip for you. It does, flights. It does everything for you. Well, that's a long running job, and it could actually take up to 5 minutes, depending on how much work that agent has to do. So in those long running scenarios, the other response that we can get back is called a task. And a task is exactly what it sounds like. It's just a long running task that's going to take a while to complete. And when it comes to our agent-to-agent protocol, when we're working with agents that take a while, what's going to happen is this task is going to come back with a few different pieces of information. First, it's going to come back with artifacts. Artifacts are where the agent stores its work. So imagine if it actually came back with a flight plan and a car rental plan and a trip plan. Well, all of those different artifacts are going to get stored in here as basically, pretty much just like this, like type text. And then what it's also going to come back with is the status. So as the agent is performing work, it's going to update the status. So it's going to start off at submitted of like, hey, I got the request. I'm working on it. Oh, it looks like I need some more inputs for me to finish my job. Or it's going to come back with like, hey, I did the work, or something went wrong and I failed, or it was canceled. So that is messages and tasks. And ultimately, once again, all this is doing with A2A is just standardizing the way we communicate and keeping things high level between messages and tasks. And, is a really nice way to make agent-to-agent communication super straightforward in our example. Okay, now the final piece of information that I want to talk about before we dive into like a super simple workflow so you can see how everything works together is, okay, well now we've talked about like this agent can send a message to this hotel agent, but like, how does it actually get triggered? Like what's happening under the hood? Well, this is where one of the other core concepts of working with the A2A protocol comes in, which is called the agent executor. Now, the agent executor, all it does is it wraps an agent. So that's why I have it wrapped right here. And all it does is it calls two different functions: execute and cancel. So let me show you this in action. So the agent executor, this is the thing that gets triggered anytime we send in like, hey, start working on this message, or hey, start answering this question. This is all it does. It takes in basically the agent executor. It basically just extends the agent executor class. And pretty much what you're going to see 99% of the time when working with an agent executor is it's going to say, hey, I would like you to, basically create this agent right here, which could be a car rental agent. It could be your hotel management agent, whatever agent we're trying to work with, we need to wrap it. And once we've wrapped it, what we can do is implement these two functions: execute, and all execute is going to do is, if we're working with CrewAI, it's going to say CrewAI kickoff, and it's going to take in our initial request. So it's going to pull in information from there. If it's ADK, what we're probably going to do is some sort, or LangGraph, we're going to do some sort of agent invoke. So whatever we need to do to trigger the agent, we're basically just wrapping it right in here in our agent executor and calling execute on it. So you're going to see this over and over and over again as we dive into our code examples. But I just want to introduce the core concept of an agent executor, which its whole purpose is to just wrap agents, because at the end of the day, agents really do one thing, which is do work. And that's all that gets triggered right here in execute. Okay, cool. Hopefully that makes sense. We're just wrapping agents, nothing wild. So now that we've gone through all the core concepts, what I want to do is one high level overview so you can understand exactly what's happening as we go from us talking to our agents to actually, getting a response using the A2A protocol. Okay, so in this example, we're just doing a super simple agent, or we have a client personal agent who does work for us. And all we're trying to do is communicate with like the weather channel. So here, using the A2A protocol, here's an end-to-end workflow so you can understand all the core concepts in one nice flow. So us as the client, we're going to send a request to say, hey, please get me the weather for Miami, Florida this weekend. We're going to send that to our client agent. So we're going to send it to ADK, and ADK is going to go, oh, okay, I can see that you've given me a remote agent, just like we normally do, like localhost 1003. And what I can do as an agent, now that I know that I'm using the A2A protocol, I can do two things. I can first check to see what agents I have available, and I can look up their agent card. So I can go for each agent I'm connected to, I can say, all right, weather agent, what can you do? Oh, I can see that you can get the weather forecast for today, for 3 days, or a week. Okay, great. I understand by looking at your agent card, I can understand exactly what you do and the core skills that you have access to. Now that I know what you can do, I now know when I can delegate work to you, which then leads us to the second part. So the second we now know what this agent can do, we can start to send work over to it. So this is where we're going to start to use RPC, which is going to allow us to send over our messages. So if you remember from earlier, we can send messages over to our weather agent. So here's exactly what's going to happen next. So in this case, what we're going to do is go, okay, weather agent, I would like to send you this message, which all it does is inside is it just contains this request. Give me the weather for this weekend. So what's going to happen is this message is going to get sent to our server. You're going to see how we can spin up our server, our A2A server. It is so easy. Once this server is running, it's then going to say, yep, I can accept these JSON requests, which include our messages. This message is going to get passed into our weather agent executor. And if you remember, our weather agent executor has a method in it called execute. And all execute is going to do is just call the proper, function to run our weather agent. That's all it does. And our weather agent is going to get the request to say, hey, what's the weather for Miami, Florida? It's going to think, and this weather agent is going to send back another message to us. So this one's coming from the user, and this one's coming from the agent. And this message is going to go to our client, and then our client's going to read out that information that's going to say, hey, the weather in Miami, Florida this weekend is nice, sunny, and hot. And then our agent is going to take in that, almost like a tool call, basically, and it's going to take in that information, format it however we've told our agent to handle requests from other agents, and then spit that back to us in a super nice and easy to understand message. So I know that's a lot. Don't worry. We're going to cover all of this step by step in phase 2 in an actual real world example where we're literally going to build out a workflow just like this, end to end, creating the server, agent executor, the agent, client agent. You're going to see all this in just a second, but I just wanted to go through all the core concepts and show you how everything connected end to end. So whenever you're building A2A agents in just a second, you can understand exactly, what it does when it comes to standardizing, how we can communicate, and some of the other core principles like agent executor, agent cards, task, messages. And don't worry, you're going to see all of this in just a second. So let's go ahead and hop over to phase 2 so we can get our hands dirty and start coding up our first workflow using A2A. Oh, and real quick, if you are looking for some additional help on the A2A protocol and want to go deeper into some few other resources, here's 2 that I definitely recommend checking out, and I'll have a link to both of these down in the description below. So the first one, there is a phenomenal video by one of the main contributors to the A2A framework by Holt, awesome guy. And in this quick LinkedIn video, it's like 7 minutes, he walks through all the core concepts end to end in a really, really nice PowerPoint. So if anything was confusing in the demo that I just did, Definitely recommend checking out his. Between my video, his video, I'm sure all the core concepts will connect. Second, once you master the rest of everything that we're going to be talking about in the rest of the video, I definitely recommend checking out the Google A2A samples repository. There's a ton of great examples from CrewAI, LangChain, ADK, and a bunch of other agent frameworks. And they have everything from, today's video is all on Python, but they have a bunch of other languages too. So you can see how to use this framework in all languages. Definitely recommend checking it out. This one is the most robust example, the A2A ADK app example. It comes with a full-blown UI, so you can actually see in real time agents talking back and forth. You can see everything. Phenomenal example, very easy to run. And then if you want to dive deeper into one-off agents and see how they work with A2A, definitely recommend diving into these sub libraries, because you'll be able to see, a Python example for, a birthday planner. Like, you'll be able to see all of that in these examples. So definitely recommend checking these out as well. I'll have a link down in the description below so you can easily go to this repo and browse around yourself. So enough of that, let's hop back over to phase number 2. So welcome to phase 2. And before we dive into the code, I just want to show you guys a quick high-level overview of exactly what we've built, so it'll make sense when we dive into the code, so you can go, oh yeah, that is the client. That is exactly what's happening. So here's exactly what we're building. First, there are really two major components to what we're going to be building today. First, we're going to build the client, and the client is just going to be a simple Python application that's just going to make a request to get the agent card, send over a message. That's pretty much all this client is going to be doing. The second major object that we're going to be working on is going to be the actual A2A server that is basically going to have our dummy greeting agent. So what I mean is we're going to be creating a dummy greeting agent who's basically just going to say, hello, how are you doing? That's all this agent's going to do. There's actually no AI involved for this one. The main reason why is just because I want you guys to get super familiar with the A2A protocol. So we don't need to get super complex, actually spinning up actual AI agents. We can just pretend that we have an AI agent so you can understand all the core principles first. So here's an exact overview of everything that's going to happen. First, you're going to see in our client, we are going to make a request over to our server to say, hey, what agents do you have? Let me see all the agent cards you have. We're going to get back a agent card that's going to say, oh, it looks like you have a greeting agent, and here are the skills of that greeting agent. From there, our client's going to go, cool, I see what you can do. Once again, we're not using an AI, so we're just going to go, okay, what I would like to do is send over a message. So I'm going to build a message and send out a message request. That's going to be super important. And I'm going to send it to our server. Once it gets sent to our server, you're going to see how our greeting agent executor, remember it has two commands, execute and cancel. This agent executor is going to execute our message and basically going to pass it to our dummy agent. Our dummy agent's going to do some stuff and send back a response to our client. And then finally, our client's going to just print out the final response. So don't worry, we're going to dive through all the code, and the core principle and core purpose of this simple example is just so you can see A2A in action. And don't worry, in part 3, we're actually going to throw in some AI so you can see all the magic happening. So let's go ahead and hop over to the code for this simple example. So welcome to the code portion of phase 2, where we're going to cover the super simple example that we talked about earlier, where we have a client and a server, and everything is going to be using the A2A protocol so you can see all the core concepts in action. Now, inside of this super simple example, you can find all the code in A2A_simple, and we are mostly going to be looking at 3 different files together. First, we're going to be using the main.py file, which is going to be responsible for running our server that's going to be waiting to receive request. And when it receives request, it's going to pass it to the agent. And actually, quick catch, it's actually not passing it directly to the agent, it's passing it to the agent executor, which is one of the other core concepts that you learned about. And if you remember, the agent executor, all it does is it wraps the underlying agent and passes information into the execute function and the cancel function. Cool. And then the third file that we're going to be working on is the client.py. And the client.py, basically what it's happening is, well, we have a client and a server, and we just need our client to send simple messages to our server so that we can showcase and actually show that the A2A or the server is running and it's following all the proper A2A protocols. So that's all we're doing with our super simple client. So let's dive into each one of these files. We're going to go from top to bottom. So don't worry, I'm going to break everything down. And as always, if you have questions, feel free to drop them in the comments down below or head over to Skool. So let's dive on in. So the first concept we're going to cover is the agent card. We talked about this in phase 1, but at a high level, the agent card is just the business card that says, hey, here's what the agent can do. Here's a quick description. So it's easier for the, whenever we're trying to figure out if we should use this agent or not, we just look at the description. Then outside of that, it follows all the other parameters we talked about earlier, such as what URL is this server running on, what are the default input and output modes, and then you're also going to see that we're going to pass in skills. So skills happen right here. In our case, we only have one skill. The only skill that we have is the ability to greet users. And all this does is it returns a greeting. And basically anytime, we're going to add our proper tags and examples, but anytime someone basically says, hey, hello, hi, this is, basically a code, or like, hey, you should infer if someone's passing in examples like this, you should call and use this skill. Okay. So now the other thing is inside of our agent.card that we didn't get to talk about earlier is the capabilities. So agent capabilities add in a few extra pieces of information to let your client agent know what your server agent can do. So if you actually look a little bit deeper inside of capabilities, you can see there's, really 3 different parameters we can pass in. So when it comes to streaming, what we're saying is, hey, does the server client support streaming? For example, is it going to return everything in one huge chunk, or is it going to return everything back bit by bit? So that's option 1. The other part that is pretty common is to do push notifications. So push notifications basically say, hey, our agent, if it's performing a task, that task is usually going to take a while to complete. So do you want to constantly send a request to the agent to check to see if it's done, or you're polling, or do you want to allow push notifications? So when the agent's task changes state from, pending to in progress, or in progress to completed, do you want to receive push notifications in real time so you can just receive events? So these are a few different capabilities that you can add in, but for simplicity, we're not going to add any of those in right now because we just want to show the basics of everything working. Okay, great. So at this point, we really just have one single agent card to represent the only agent we have running in this server. Speaking of servers, we have to set up our server next. Now, what A2A has done with the A2A library is they've actually made a super simple request handler and server so that all you have to do is say, all right, I'm trying to spin up a server that wraps an agent. And what I would like you to do is make a default request handler that's going to wrap this greeting agent executor. And we're going to hop over to greeting agent executor next, so this all makes sense. But if you look at our greeting agent executor, you remember all this does is it wraps pretty much an agent, and then it helps support 2 different calls. In our case, that is execute and cancel. So you can see actually if we just go to the agent executor class that comes from A2A, you can see, hey, this is just an abstract class. It's really just an interface. And it basically says hey, there should be an execute method and a cancel method that you have to create. And then it basically just says hey, the execute function should just, call the agent's logic and trigger it once it gets started. So you can see this is pretty straightforward. This is what you'll see 99% of the time when working with A2A agents. Now let's dive a little bit deeper. So there's actually 2 pieces of information you have to pass into execute. There is context. So context usually can just include some additional information about state. You can also pass in some other fancy functions in here. It's kind of overkill for this simple example. But the most important thing is going to be the event queue. Now, what this server does to avoid getting your agents overrun is it has an event queue. So basically what's happening is you have this event queue, and what we're going to do is send and add events to the event queue. And then whenever they're done, the event queue is basically just going to give us the results. So it's just a simple queue that's going to, basically hold all of our work. So here's what we're gonna do next. As we've discussed, the whole point of the agent executor is to call execute on the agent. So in our case, you can see, oh, we have a simple greeting agent and we're calling invoke on it. In our case, as discussed earlier, this agent is just, we're pretending it's an AI agent, and all it's doing is every time the greeting agent runs, it has an asynchronous function called invoke, and all it does is it returns, hey YouTube, make sure you like and subscribe. That's all the function does. So what we're going to do is invoke that function, and then when we get the result back, all we're going to do is say, hey, there's a new agent text message. This comes directly from basically the A2A library. There's a message, and all this does is it creates a new message. So in our case, we just have to pass in the text. We could also pass in context ID and task ID if we wanted to include it. but most importantly, it's going to create one of those messages. So going back to core concepts, we said, hey, a message always has a role, parts, and some other additional information like message ID, task ID, and context ID. So all it's doing is it's creating a message that's going to eventually get sent back to the client. That's all that's happening. So we're just adding it to the queue, and then the event queue eventually will pop the message back to go over to the client. So yeah, super straightforward when it comes to the agent executor. Don't worry, in phase 3, you're going to see us actually build some real agents, and just wanted to focus on the core fundamentals here. All right, let's hop back to it. So in our case, we now have our default request handler that we're passing in our greeting agent executor, which should always just return, hey, like and subscribe on YouTube. And the other part of information that we have to pass in is basically a task store. So a task store is, as you remember, a task is more of those long running jobs. So we just need somewhere to store them. In our case, we're just going to do an in-memory task store, which is just going to, hey, while the application's running, keep up with those tasks. Whenever the application closes down, we're going to lose access to them, but perfect for demoing. All right, so now that we have this request handler, what we can do now is spin up our A2A application. So this is where the rubber meets the road, guys. And the only 2 pieces of information you need to pass into here are going to be the HTTP handler. So this is like, hey, as you receive a request to kick off work and do stuff with the agent, you should send it to this endpoint right here that we just stood up. And then also, I want to give you more information about the agent that is we are going to expose to the world. So in our case, we have our agent card right up here, and we're just going to expose it. So anytime anyone hits localhost port 9999 / well-known agents, they're going to be look up, oh, I see you have a greeting agent and it has this skill. Don't worry, you're going to see this in a second with a client, but this is all we have to do to spin up a server that's A2A compliant, and definitely like completely, hopefully you guys can see just how simple this is. Fantastic. So now the final thing, once we have our server, we have to run it. So what we're going to do is use UVcorn, which is basically going to run a server, and we're going to run it on localhost port 9999. So that is everything that we need to do to spin up our server, which leads us to our next part, which is going to be like, okay, well, how do we communicate with this server? So that's where our client comes in. So let me just walk you through the client from top to bottom so it all makes sense. And just a quick update, all the client is doing, just a quick recap, is it's going to fetch the agent card, and then after that, it's going to start to send some messages. It's all hard-coded. There's no actual agents or client work happening right now. I just want to show you guys some of the core principles, such as like getting the agent card information and sending a request over to your A2A server. So let's walk through it. So first thing that we're going to do is we need to figure out what our client has no idea what our A2A server can do. So we need to first make a request and resolve what capabilities our server has. So in our case, we are going to create an A2A card resolver, and this is just going to be a quick HTTP client. And we're saying, hey, you need to be making a request over to port 99999, which is basically everything that we set up right here. That's all we're doing. Great. So now that we're saying, all right, A2A card resolver, now that we have created you, what we're going to do is we are going to attempt to fetch the public agent cards from that endpoint. So all we have to do is say resolver get agent cards, and it's going to return a public card. We're going to print out all the results so you can see, oh my gosh, it does have the card name, it has the skills, it has everything. Once we have that final agent card, if everything worked successfully in our try clause here, we can then move on to phase 2, which is going, okay, well now what I would like to do is I would like to make an A2A client that knows what agents it has ability to make contact and request to. And once we have this client, we're going to work on spinning up an A2A client. This A2A client basically has access to start to send information over to the agents it knows it has access to. So now that we have our A2A client, what we're going to do is start to create messages and start to send a message request. So let's walk through this part by part. So first thing, a message has to say who's sending it. So in our case, we're going to say a user sent it. And a lot of these types, everything's coming directly from the A2A types. So pretty much everything you're seeing, guys, just, you can look up top and see A2A has made everything super easy for you and added a type for everything to make it super easy to use. From there, we're just going to come up with a random unique ID for the message ID, and then we're just going to send over a quick message. So if you remember, a message actually consist of parts. And more specifically, we are sending text. So we're going to send a text part, and all it's going to say is, hey, how are you? Then once we have our message payload ready, we are going to create a send message request object that has a unique ID, and all it includes is the message that we want to send over to our server. Then once that's done, we now can have our A2A client send a message that has our request, and we're going to wait till we get back a response. Once we get back a response, we would expect to see this quick message right here that says, hello, YouTube. That's what we would expect to see back. And then we're just going to print the response so you guys can see it in action. So no more talking about the code. Let's actually hop in and run the code so you guys can see us spinning up the server, running the client, and have our client sending messages over to our server. So let's go ahead and get everything up and running. Okay, so now it's time to start running our server and our client so you can see everything in action. And what you'll want to do is head over to the README file that I've created for you guys, because in this file, I walk through the entire process of getting everything set up so you can run this locally on your computer. Quick reminder, you can download everything for free down in the description below. So let's follow these instructions. So first things first, what we want to do, I already have UV set up on my computer, but now what we want to do is make sure that when we are inside the A2A simple project, we set up a virtual environment and run it. So this is exactly what I'm going to do. So we're going to CD into CD A2A simple. Once we're in here, we're going to run everything, create our virtual environment. Then we're going to activate it. So boom, now you can see we are in A2A simple. Everything's looking good. And what we want to do now is we want to run two different terminals at the same time. In terminal one, what we want to do is we want to run our agent. So that has our server. So you can see this is what we want to run in one terminal where we have our server up and running. So to do that, all we need to do is, let's actually get this back. All we want to do is just run uv run dot. That's all we have to do. And this is going to install the necessary packages. And as you can see, it says our server is up and running on localhost port 9999. And that's exactly what we'll do. Oh, sorry, wrong link right here for you guys. But yeah, you can see that's exactly what we have set up right here. Okay, cool. So what we need to do next is in our second terminal, we want to run our client that's going to start making requests to our server. So all we have to do over here is, once again, we have to activate our proper source. So bin activate, and now you can see we're in A2A simple. And now what I can do is run our client. Now this is going to happen pretty quick. Don't worry, I'm going to walk you through everything that happens, but it's going to basically we'll just quick reiterate, our test client. All it's going to do is it's going to instantly run, get the card. Once it has the card, it's going to send a message, and then finally it's going to print the response. So let me show you this in action so you can see A2A officially working. So we're going to run it and boom, it's done. And the reason why, like I said, there's no AI. This is just pure A2A protocol. We're just looking at the bare bones in this one. So let's actually analyze the results. So first things first, on our server, you can see that it received a GET request, and you can see it received a GET request to well-known agents.json. This is, if you remember from earlier, this is how you look up the agent card. So this is when we were like, hey, what agent cards do you have? Well, this is when we made a GET request to this endpoint right here. So you can see it officially did it. And you can see we got back a nice dictionary that described everything that was inside of this agent card. So you can see, yep, the agent that you're looking at, it's a simple agent that returns a greeting. You can see that it has some skills, such as it returns a greeting with examples, IDs, and the different text modes. So in our case, we didn't really say anything because everything was just text. You can see the URL, the version, everything about it. Next, you can see inside of our terminal that what we wanted to do is set up our client so that we can use that agent card and start to send messages to that agent. So we initialized our client, and let me just walk you through because I want this to be super clear. So let's go back. So you can see we're now here to where we just created our client using our specific agent card. And now what we can do is we're going to say, all right, I'm going to send a message to this client. And our message, quick reminder, all it has a message payload with a role and some text. How are you? And then we actually send it. So that's what you can see actually happens right here. So we send the message and then we end up getting a response. Inside this response, you can see that we got a result, and the result actually is of type message. So you can see what type it is right here. It's a message, it has a unique message ID, and in that message, you can see it comes with parts. And in this case, it's a text part, so it's a quick text response. And then you can see it includes the exact message we expect to see, which is, hello, YouTube, make sure you like and subscribe. So yeah, you can see that is super straightforward. And just quick recap of everything that just happened is A2A made it very easy for us to standardize communication between clients and servers, specifically agents, clients making requests to different agents on different servers. It made the entire process super seamless and standardized everything. So if you have questions on anything, feel free to drop a comment down below. Hop over to the weekly free coaching calls I have inside the AI Developer Accelerator School community. Always happy to help over there. But now that you've seen the basics, what we're going to do next is we're going to head over to phase 3, and we're going to dive into a more complex version where we actually have full-blown agents running. Nothing's dummy. No more dummy agents. We have full-blown agents up and running, and you're going to see how they can handle requests, generate responses, send it back, all done over the A2A protocol. So let's hop into phase 3 and dive into exactly what we're going to be building. Okay, welcome to phase 3, where you guys are going to see how we can take everything we've learned about the A2A fundamentals and actually start to build out a more real-world A2A workflow. And I'm super pumped for this one because you guys are going to see how we have an ADK agent that's going to be our host agent, how it's going to use the A2A protocol to communicate with different agents of all different types of frameworks. So you're going to see it connect to another ADK agent, a CrewAI agent, and a LangGraph agent. So this one is going to be everything that you could ever think of. Super excited for you guys to walk through this one. And what I've tried to do in this example is just make it as the concept as simple as possible, so we can just focus on the core fundamentals of A2A. And that way we're not getting too in the weeds with spinning up crazy agents. So super excited for this, and let's walk through the example that we're working on, understand the tools, what's getting communicated, so that it all makes sense. All right, so here is the ultimate goal for this example that we're working on together. We are trying to use agents to schedule pickleball so we as friends can play. And what we're going to do is use agents to help us determine our friends' availability. And we're going to do some tool calls as well to figure out when courts are available. So based on everyone's availability, what's available on the court, we're then going to schedule time for all of us to play. And super excited for this one because this is probably going to happen in the next few years, to where everyone has their own personal agent that's external facing, that other agents are going to communicate with to schedule, times to do stuff, send emails to each other. So eventually it's all going to be agent-agent communication. So I think this is actually a really practical example. So let's actually walk through everything end to end so you can see how it all connects together. So first things first, we have a host agent, and the purpose of the host agent, it's basically our personal agent. It's the agent that we communicate with that goes off and does work on our behalf. Now this host agent is going to have access to a few different tools. So it's going to have access to a local pickleball court, and it's going to have access to 2 different calls. It's going to be able to say when the court has availabilities, and then whenever we find a time that we like, we can actually reserve a court. So that's the simple side. You guys as ADK experts, if you haven't checked out the ADK masterclass, if any of this doesn't make sense, definitely recommend checking that out. But I'm assuming you guys know how to add tools to your ADK agents. So then what we're going to do next is say, all right, well, because we're trying to use A2A to communicate with other agents, we're actually going to be using A2A protocol to communicate to 3 other agents. So in our case, we're going to be talking to 3 of our friends who each has their own external facing public agent. So we're going to be talking to my wife's agent and our friends to see when they're available for pickleball. And as you can see, each agent uses a different framework, which is a core concept of A2A. A2A doesn't care about the underlying agent that's in the box. Because we're using agent cards and we're using the A2A protocol, we treat each one of these agents as a black box, and we just assume that they're following the A2A protocol. So they're going to be able to receive requests and send us back answers. We don't care how the agent works on the inside. All we care is what the agent can do and send back to us. So, we treat it like a black box. Anything that happens inside, hey, that's up to you. I just expect you to handle requests that I give you and you to send me back information in the appropriate format. So here's exactly what each one of these server agents is going to do. Each one's using a different framework, and each one of these agents has access to its own tools. And in the case of each one of these agents, you can see it pretty much is using the same tool, but just for a different framework, which is going to be get availability. So we're just trying to see, hey, when are you free so that we can play pickleball? So now that you've seen everything at a high level, I want to cover next steps because this example is a little bit more in depth, but I just want to give you a roadmap of what we're going to be doing as we go through this example. So first things first, we're going to dive into the host agent, and this is our client agent right here, our personal agent, and we're going to go through how this agent works at a high level. So we're going to look at the workflow first so you can understand the core concepts that we need to implement before we dive into the code, so that you can understand, oh, okay, I understand how you're connecting to remote agents now. Oh, I understand why we're using this tool call. So we're going to look at the workflow first, then we're going to hop over to code, and we're going to repeat this process for each one of our different agents so that you can see exactly how the same workflow works for ADK, CrewAI, LangGraph, and so you can see a little bit of the code behind the scenes. Once we've gone through everything, we're then going to run the entire workflow so you can see everything working. And I'm super excited for you guys to see this because A2A, the first time I was trying to build all these examples, I was getting so frustrated because I couldn't understand how everything connected. And in the rest of this scenario, you're going to see real world agents getting broken down as simple as possible so you can master A2A and be an expert too. So, all right, so let's hop over to our first step, which is going over the workflow for our host agent. So let's hop over to the workflow. Okay, so here is a complete breakdown of everything that we're trying to do with our host agent when it comes to running this agent ADK web and clearly breaking down the workflow for how this thing works. So quick recap, what is our goal? We want to run our host ADK agent. We want to run it inside of ADK web right here. And we want to be able to send requests to each one of our remote agents. And we want to use this all using A2A. So here's exactly what we should have set up by the end of this phase. So we should have our host agent using A2A to where we can easily look up using agent cards to see which friends we're connected to. Once we know we're connected to our friends, we should be able to send them out questions. And using the A2A protocol, which is all about sending messages, our ADK client agent should be able to send messages to each one of our friends. Our friends agents should take that request and send things back to us. And that's exactly what we should have set up for this project. So here is exactly what we need to do when it comes to a workflow to get this set up. And this was the most confusing part at first because you have to worry about host agents and server agents. So just know host agent is going to be set up differently than server agents. And I'm going to break down host agent in this example. And then when we head to the server agents, you'll see a breakdown of all of those. Okay, so high level overview. What are we trying to do? Well, an agent really comes down to two major things: prompts and tools. When it comes to prompts, what we're ultimately trying to do is set some core instructions of like, hey, you're trying to help me schedule pickleball games with my friends. And then at the very end, what we want to do is dynamically pass in all of the available agents. To determine available agents, that's where we're going to eventually, you're going to see, we're going to pass in some like remote URLs to say like, hey, Carly's agent's running on this server, Nate agent is running on this server. And depending if we're able to successfully connect to these servers, get the agent card. If we get all the information, we're going to dynamically add them to our available agents. So you're going to see all of this happen in the code section, but I just wanted to give you a high level overview of that's exactly what we're trying to do. Next, once we know what agents we have access to, we then want to start to be able to send requests to these agents. So you're going to see we're going to basically start to use tools to make this happen. So the two major tools you've seen so far are going to be hardwired tools such as, list the courts and book the courts. But the new tool that you're going to see is going to be the send message tool. This send message tool is going to take in our friend's name. So like, oh, I want to talk to Nate. And then whenever I talk to Nate, I want to pass in this message. So, very A2A protocol to where we say what agent we want to send a message to, and then we actually just pass in the raw message. So these are the main core objectives we're trying to complete when it comes to building out our client host agent. So let's go through the exact workflow of how we set this up because it can be a little confusing at first, but I'm going to break it all down for you. And I do think it is important for just overall to make sure we're on the same page. When I refer to host agent, there's actually going to be two agents or two host agents that you're going to see inside of the code today. There's just a generic Python host agent. So this is going to be a regular class. And this class is going to have an agent, and that agent is going to be the ADK host agent. So just know we're going to be doing some basic Python object-oriented programming where we're going to have a class for a host agent, and inside that class, we're going to have our actual ADK agent. So just wanted to point that out before I dive into the workflow because it can get a little confusing. All right, so here's exactly what we need to do to set everything up. First, we are going to create the Python class host agent. And for each one of our friends, we are going to pass in a remote URL. So we're going to say Carly's on this server, Nate's agent's on this server, and Caitlin's agent's on this server. From there, we are going to basically do some prepping to check out each one of our friends to see like, hey, are they online and are they not online? Because ultimately what we're trying to do is set everything up for our prompt to figure out what are all the available agents. So what we're going to do is go, okay, for each one of those URLs you just gave me, I'm going to fetch the agent card, save all the information about each one of the agents I find. So, oh, Carly's agent can do this. Nate's agent can do this. And I'm going to save it to our Python host agent class. I'm going to save it to self agents. So I'm going to save it to right here. Great. So now, after we have fetched all of our remote agents, we're going to actually create the ADK agent. And whenever we're creating the ADK agent, we're going to say, okay, hey, I have a list of agents I've already found for you. These are all remote agents, and I want to add them at the bottom of our root instructions. Basically do this right here. Great. Now, once we have our agent up and running, we're going to set up the server. We're going to run the server. And once things are set up, we can then start to send messages. So you're going to see whenever we have the agent up and running, we can say, hey, what's Carly's availability? That will trigger the send message tool call. And this is going to pass in Carly's name. It's going to make sure that we still have an active connection to Carly. And then it's going to send a message using the A2A protocol to Carly. And then we'll get back a message. So that is everything that we're about to do inside the code. And I just wanted to give you a run through before we dive into the code because it can be a little bit more confusing because there is more code involved than just plain agents. Because we kind of have to wrap everything to make sure it's following the A2A protocol. So let's hop over to the code so you can see all of this in action. Okay, so now it's time for us to look at the code that is going to run our host agent that's going to connect to all of our friend agents. And I think the easiest way to understand this code is to work backwards. So we're going to basically look at creating our agent and work backwards so we can see all of the different steps discussed in the workflow just a second ago. Okay, so if you're familiar with using ADK, the main thing that you have to create in order to run ADK Web is a root agent who's going to handle all the requests. And this root agent needs to live inside of a file where you usually have access to your tools. So that's exactly what we have set up for our host agent. And what you'll see is we want to create a root agent. So how do we do that? Well, in our case, it comes to the get initialized host agent. And all this function is trying to do is say, hey, I have a bunch of different friends that I would like to connect to, Carly's agent, Nate's agent, and Caitlin's agent. And what I would like to do is create that host agent class. And remember, this is the Python host agent, not the ADK host agent. So what we're going to do is say, okay, I would like to create this host agent using our friends' remote agent addresses. So if we go look at the create function, what you'll notice is we are using a little bit more fancy Python right here. So what we're doing is creating a class method. And what we're trying to do is say, all right, I'm trying to create an instance of this class. But before you create it, what I want you to do is call basically the async initialize components. Long story short, there's a bunch of issues when it comes to creating asynchronous classes when working with ADK because ADK just expects a regular agent. So we're trying to have to do some workaround to create that regular plain agent that you're used to using. And we're just having to do a bunch of workarounds. So that's exactly what we're doing here. So this workaround is basically going to do the asynchronous work. And after it's done with the asynchronous work, we're just going to return the regular ADK host agent. So let's look at what we're trying to do. So in our case, we are trying to initialize a new class that has access to our remote agents. So let's go look at what this does. So when it comes to basically the async initialization, you can see we have our remote agents right here. And all we're doing is saying, hey, for each one of the agents that we have access to, here's their address. I would like you to do the A2A card resolver. Same thing you saw in the simple example. And for each card that we get back, what I want you to do is create a remote connection so that we have access to it at a later point. and we're going to save access to that remote connection. So later on, when we try to say send message to Carly or send message to Nate, we can access this connection right here. And the other thing that we're going to do is you can see along the way, what we're doing is we are building up a list of cards. So you can see we have all of these cards right here. Well, after each time we make a card, we're saving it to a dictionary. And at the very end, what we're going to do is say, all right, with all of those cards that you just collected, what I would like you to do is just make a simplified agent card list. So it's basically we have the business cards for all of our friends to where we can say, oh, Carly's agent, well, her name is Carly Agent. And the description is like, oh, this Carly agent handles all of Carly's availability requests. So we're basically just creating a huge list of dictionaries so that we can say, oh, here's what Carly's agent does. Here's what Brandon's agent does. Nate agents, Caitlin agents. All of our agents are going to go right here. And we're going to save everything to the self agents value so that we can access it later on. Because remember, we just want to save all of our agents to the self-agent property because later, when we go to set up our route instructions, we want to know what agents we have access to. Okay, great. So now that we have called this function right here, what we're going to do, so basically creating the initial instance of our host agent is done. And now what we're going to do is start working on actually creating our agent. So you can see this is us creating the host agent instance. So this is the Python class. Now that we have the Python host agent set up, what we want to do is call CrewAI. CrewAI is actually going to create the ADK agent. So you can see this is all coming from the ADK class. And this is what you're probably familiar with if you've worked with ADK before, where all you have to do is say what model you're trying to use, the name of the agent, and then we get to set the route instructions and our tools. So when it comes to route instructions, you can see this is actually going to be a basic function that is going to call and return a simple string. So you can see here that this agent right here is basically saying, hey, you're the host agent, you schedule pickleball games. And most importantly, here is a list of all the available agents that you have access to. And if you notice, this self.agents is the same thing that we set up earlier right here. So when we were going through initialize everything, where we said, hey, please add Carly's agent, Nate's agent, and Caitlin's agent to self.agents. That's exactly what we're doing right here. Great. So now when our agent's running, it knows, oh, I have access to all of these friends. I can easily, make calls to them and I understand what each one of them does. Okay, awesome. So now that we have set up our route instructions, the final thing left is there is the send message tool call. And the send message tool call, very straightforward. All it does is it goes, hey, you are trying to send a message to a friend and you're also trying to pass along a task. So this is like, hey, Carly, what is your availability? Hey, Nate, what is your availability? So what we want to do first is we just want to make sure that that agent actually exists. So at the beginning, you remember we set up our remote agent connection here where we're like, hey, Carly's agent, use this connection. Well, now it's time to actually use that. So we're going to say, hey, does Carly's agent actually exist in this dictionary? Okay, cool. We can send a message to her. Are you trying to check send a message to Bob? Well, Bob doesn't exist. Therefore, I'm not going to actually send a message to him. So once we actually know that the agent exists, we can pull out that agent connection. And once we have that client connection, we can actually start to send message to them. So this is where you're going to see we follow all of the normal A2A rules to where we can start to create a message. So this is going to be our message payload. And then you can see, all right, I would like to send a message request. Same thing that we've always done. And now you can see we pass in a message ID, and then we can actually pass in the send message parameters. And this is where we're going to pass in our payload. We're like, hey, this is coming from the user. Here's the task or the message. Hey, what's your availability? And then all we do once we have this message request, we can actually send it over to that different server. So we can say, hey, Carly agent, please take action on this message. From there, this message is going to take a second to process. The AI is going to handle and do all of its tool calls. But according to A2A, we don't care what it's doing internally. We're just going to wait for that agent to send us something back, either a message or a task, if you remember back to the initial overview. In our case, all of these are super quick tasks and super quick things. So we're just always going to get back a message. So you can see once we get back this message, what we're going to do is just log it so you can see what got sent back to us. And then what we're going to do is just do some basic validation. So we should expect to see like, hey, we should basically expect to see a message. We shouldn't expect to see a task. So what you can see here is we're just doing some basic validation. And what we're going to do is like, okay, cool. I understand in the message I got back, what I can do is just basically do a dump of all the raw text that was sent to me. I can load it up and then I can create a new artifact. So you can see right here, hey, get the results of this message. I want to get the artifacts. Inside the artifacts, I would expect to see all of the different pieces of information, such as like the text that I should get back. And once I have that text, I'm just going to return it. So this is like the basics of a regular tool call. We're just going to get back all the raw messages from the server agent. So Carly's agent's going to say, hey, in a text chunk, it's going to say, hey, I'm available tomorrow from 5 p.m. to 8 p.m. And that's exactly what we're returning at the end of this tool call. Okay, so that is the last major complex part of working with this A2A agent. Quick recap, just because I know there's a lot of moving parts here. We need to create a Python host agent who's responsible for handling all of the remote connections. Then we're going to create our A2A agent. Once we have our A2A agent, everything is looking good, because then all we have to do is just return this root agent so we can run A2A web. So I can actually show this to you real fast. So we're in the host agent code. So I could just run A2A web. This will spin things up, and we can see it's going to pop up a nice little terminal for us right here. And you can see we have our host agent. Everything is looking good. And we can say, what friends are we connected to? And then this is actually going to check to see which friends we are connected to. In the background, I've already had all these other agents spun up, but you can see everything is working properly. We can see what friends we have access to, and we can actually send message to them. So I can say, what is Carly's availability tomorrow? And what it'll do is it'll actually call the send message tool that you've just set up. It's right now triggering things off. Carly's agent's doing all the work. It's sending back a response. So you can see it's sending back all the chunks right here, and it goes, and Carly's agent responded with Carly's available from these times. And you can see that's exactly what we printed out right here. All right, cool. You guys just set up your client agent, and now we're going to hop over to actually setting up all of these different remote agents for Carly, Nate, and Caitlin using A2A, CrewAI, and LangGraph. So let's hop over to all of those so you can see how we actually set everything up. Okay, so now we're going to look up how we can set up our remote server agents for all of our friends, everything from LangGraph, CrewAI, A2A. And before we dive into the code, I just want you guys to see the exact blueprint that we're going to be copying and pasting for each one of our remote agents so that you can see the core patterns, so that when you're building your own remote agents, you know exactly what you need to do. Okay, so let's start at the basics. So per usual, what we need to do is create a regular agent. So whatever agent framework you like, you'll use LangGraph, CrewAI, A2A, and you'll create your agent just like you normally do. You won't change anything about the actual agent setup. You're also going to add all the normal tools like you would do for each framework. So for CrewAI, LangGraph, each one, you're going to follow the tool specific patterns for creating the tool. In our case, every availability agent we're trying to set up, it's just going to have a single tool, which is just going to be list availabilities. So you're going to say, when are you free? So we can play pickleball. Great. Now, once you have the agent and the tools set up, what we're going to do next is we are always going to wrap each agent inside the agent executor. Because if you remember, the agent executor is what's going to bridge the gap so that when we are using the A2A protocol, our remote agent can handle receiving requests. So this is when we're going to say like, hey, tell me when you're free. And the agent executor is going to kick off execute, and execute's going to call agent invoke to trigger the LangGraph agent, or it's going to call crew.kickoff to kick off the crew agent, and so forth and so forth. So this is just remember, every time you're creating your agent to use A2A, you have to wrap it in agent executor. Fantastic. Once we have our remote agent wrapped in an agent executor class, we now can move on to the final part, which is kicking off our remote server. And our remote server is pretty much going to follow the exact same format every single time. First, we are going to create our agent card, which is going to include all the skills, such as like, hey, this is Carly's agent. I can tell you her availability, and my skills are to give you her availabilities. Next, we have to pass in our agent executor to the server, and then we'll pass in that agent executor to the request handler. Once we have all of the request handlers spun up, we can then basically create and run our remote agent server, which is just going to be sitting there waiting to receive requests. So this is the exact template we're going to copy and paste. And at this point, really the only thing we're going to be changing out is whatever underlying framework we're using as we go through the rest of this example. So we're going to first start with ADK, then we're going to move to CrewAI, then we're going to go to LangGraph so you can see all of this in action. So let's go ahead and hop over to our first remote agent using ADK. All right, so now it's time to look at our first remote A2A agent, which in this case is going to be an ADK one. So what we're going to do is work inside out, just like you saw in the overview, where we're going to look at the agent first, agent executor, then look at the actual server so you can understand how everything connects. So when it comes to creating the agent, this part is super straightforward. If you are familiar with ADK, what you do is you just create a general agent where you pass in the model you want to use, the agent name, and then you just pass in all the instructions and the tools. In our case, our Carly availability agent is just going to get Carly's availability. So this is the only tool call we have where we just pass in a start date and an end date, and the agent tool does its magic to determine if Carly's free or not. When it comes to creating Carly's calendar, we just have a simple function that's just dynamically making up a fake calendar of when Carly is free and not free. Super, super straightforward. Now, what we're going to do next, let's hop over to the agent executor within Carly's agent. And what we're going to do now is go through the agent executor. I will say agent executors are getting more involved now that we're actually using agents instead of just faking AI calls. So if you remember, when it comes to the agent executor, the most important part is going to be the execute function. So let's look at the execute function and walk you through exactly what's happening. So when it comes to executing the function, what you'll notice first is the task ID and context ID that we're passing over whenever we have our client agent, that's our host agent sending a request. It always includes that context and task ID. So once we have that piece of information, what we're going to do is work on the task updater. So if you remember, when it comes to working on task inside of A2A, task have states such as like submitted, in progress, success, canceled, failed. So this is just the general task updater for handling requests. So our task updater, what it's going to do is take in the event queue. So this is every time we submit an event, like a new request, we're just adding it to the event queue and those different IDs. Once we have our updater, what we're going to do is say, hey, the task is submitted. So like, hey, we've submitted the task to be worked on. We'll keep you posted as we make progress. After we've submitted the work, what we're going to do is say, great, now it's time to start doing the work. So, just mark the task as it's working and we'll keep you posted as we wrap this up. So now we get to the part to where, okay, we now actually want to start processing that request and actually taking action on the message you sent over to us. So whenever Brandon's host agent says, Carly, when are you free? This gets sent over to the process request function. So you can see all we're doing is taking in the raw text and actually mapping it so our local agent can use it. Think of this as just a straight up mapping to where we get raw text from the outside world and then we have to map that text so it can be used inside of our agent. We're basically adhering to the A2A standards. So we're saying, great, I received a message. This message was going to have a bunch of parts. In our case, it was just a text message saying, when are you free? And we can use when it comes to ADK, there's a lot of built-in tools that we can use. So we're going to be using we're going to be using the convert A2A to parts function that we can actually create. So this is just basically going to be a function we've created that's going to wrap the A2A part that we received and convert it over to a format that we can use for our actual model. So that's all we're trying to do here. And at the end of this, we're just going to have a list of parts where it's like Brandon's message said it was from the user, the agent was Brandon, and he was saying, when are you free? Once we have that message set up, what we can do is trigger process request. And this is where the actual work of ADK is going to happen. So if you're familiar with ADK, you know there is a concept of a session. A session is nothing more than a list of messages and a basic state. So what we're going to do is say, okay, I would like to get the session if it exists. So I'm going to get the session for Carly's agent. Here's the session ID. And if the session doesn't exist, Don't worry, I'll just create a new session and we'll use that. Once we have the session set up, we're going to get the session ID. And then all we're going to do is we're going to run the agent. So the run the agent is going to say, hey, here's your session. You probably have a bunch of existing messages in here. Here's the new message. If any of this is over your head, definitely recommend checking out the 80K crash course I've created for you guys. But what we're going to do is just run the agent, and the agent is going to stream back a bunch of events. So what we're going to do is just wait until we get the final response. Once we have the final response, which means the agent's done with its work, we're going to convert the 80K parts back to an A2A compliant message so that we can send it back so that the host agent can process it. So we're just going to convert everything back from 80K to A2A, and then we're going to say, hey, task updater, I just finished wrapping up this task. I'm going to update our artifacts, because you remember, tasks have artifacts, and those task artifacts are what we're actually going to show inside of our agent back on the client side. And then we're going to mark things as completed. Once things are completed, our host agent goes, oh, thank you. I can now see that this work is done. I can access all the artifacts and I can see Carly's availability. And that's pretty much all we're going to be doing at a high level. That's literally all we have to do in order to process the request, because we're just going to wait for that to finish. And it's just going to send back Carly's free tomorrow from 5 p.m. to 8 p.m. That is, at a high level, all we have to do inside the agent executor. So what we can do next is hop over to the main.py file. And this is the actual server that is going to run Carly's agent executor. And this looks exactly like you guys have seen in the super simple example. So where all we do is we create an agent card. An agent card has skills and it has capabilities. In this case, we're adding in streaming just to showcase some of the cool new features. And once we have this agent card up and running, all we have to do is now basically go through the entire process of setting up our server. In our case, there's a little bit extra work because we have to create our agent executor. But in order to create our executor, we have to set up an 80K runner. An 80K runner, literally nothing more than just saying, what's the application you're running? What agent are you trying to run? And then you have to set up some memory and session. Super straightforward. If you've used 80K, definitely recommend, once again, checking out the 80K crash course. So once we have our agent executor up and running, we then do the normal default request handler where we say, every time we receive a request, who do we send it to? Oh, we always send it to our agent executor. Then finally, we're going to spin up our server where we pass in our agent card so people can see what agents we have under the hood. And every time we send a message to this endpoint, we have our request handler. Finally, we just run this bad boy. So that is all you need to do to run an 80K/A2A compliant agent. So that is the 80K in a nutshell. So what we're going to do next is hop over to CrewAI because it's the next simplest one. It's actually the simplest one to spin up. So we're going to hop over to the CrewAI one so you guys can see how we can actually set up the code to run a A2A compliant CrewAI agent. All right, so now it's time for us to look at how we can create a CrewAI agent using the A2A protocol. So everything works with our host agent. So for our CrewAI agent, this is going to be under the Nate agent. And what we are going to have is we're going to start off with the basic exact workflow we just did with the 80K agent. So we're going to go agent executor, main.py file. So first things first, we're going to create our generic class. And the whole point of this class is to return back our agents that we're going to call later on. So what do we have in here? So if you're used to CrewAI, the main thing that we're going to do is create just a single agent. So this agent is going to be our personal scheduling agent. The goal is to check calendar and answer questions. Here's a basic backstory. And what you'll notice is I do not create any task in this workflow just because it's so straightforward. There's no no default task. Instead, what we're going to do is down here, whenever we call invoke on this agent, what we're going to do is generically create a task right when we need it. So we're going to say, hey, answer the following question about this, this question. Here's today's date. We'll then create the task and then we'll tie everything together inside of a crew. So we're going to go, all right, crew, I would like to pass in this agent that's going to answer questions about my availability. Here's the specific task where you're going to answer this question right here. And this is just a basic sequential crew. And then we're going to kick things off. So this is all we need to do. And then we're just going to return the result as a string. Great. So then what we're going to do next is hop over to our agent executor. And this is where things are going to be pretty much copy and paste from what you saw in the 80K agent executor. So let's cover once again all the high level things. And this one's a little bit more straightforward since we're not working 80K. It's a lot more like type restrictive on like you need to have parts, and parts are text, or, you know, yeah, there's a lot more to it. So this CrewAI example is a lot more simple. So you can see, same thing. We're going to, whenever we create our agent executor that inherits from agent executor, whenever we create this class, we're going to initialize it with our CrewAI scheduling agent. Then the main thing we need to implement is the execute function that's going to handle requests. So same thing, we are going to first make sure that we are given a task ID and context ID. Once we do that, we're going to once again create our task updater that's going to have access to our event queue and all the other necessary pieces of information. And instantly we're going to say, hey, I just received the request and I'm starting to work on it. What we're going to do from there is we just want to make sure that everything is valid. And if it is, what we're going to do is get the user input. So this is going to have the raw piece of text. So yeah, just extract text content from the user message. So this is where we're going to say like, hey, Nate, what is your availability tomorrow? So we're going to take in that query and then we're going to invoke our agent. So this is what we're going to do right here. We're going to invoke it. And this is where it's going to say, hey, Nate, what is your availability tomorrow? And it's just getting passed into our agent just like we normally do. Fantastic. So what we're going to do is we're eventually going to get back a result. And if things go great, all we're going to do is convert that result back into the A2A compliant part, which is just going to be a text message. And then we're going to say, hey, I just uploaded an artifact that has the final answer and my work here is done. So that is how you create a A2A compliant Crew agent with the agent executor. And now we can go over to the final part, which is basically going to be spinning up our agent card, you know, rinse and repeat. You guys are pros now. Hopefully this repetition is helpful though, so you can see the core patterns. And hey, as you're going off and building all your own agents, you're most likely going to be using a Crew agent, an 80K agent, a LangGraph agent. So everyone gets to win here. So same thing, I'm not going to repeat this, but basically we have skills. Skills go to an agent card. Once we have an agent card, we create a request handler. A request handler points to our agent executor, and then our agent executor, once we have that spun up, we create our server and then we run this bad boy. So that is the Crew A2A compliant agent in a nutshell. Now what we're going to do is hop over to the LangGraph one. This one's a little bit different. There's more, just with LangGraph, there's more complexity, but I will walk you through everything so you can understand exactly how it works. So let's hop over to our final one so you guys can see it in action. So now it's time for us to cover our final remote agent, which is going to be a LangGraph agent. And once again, we are going to go from agent executor all the way to our main.py file, which is where we're going to run our server. So let's walk through how we're setting up this agent to tell us what is Caitlin's availability. So what we're going to do in this one is we are going to be using LangGraph, and to start off, obviously we're using LangGraph. What we're going to do is start to set up our graph. So what we need to do is to create a React agent, which stands for reason and action. And what we need to do is pass in our model. In our case, we're just going to be using the Gemini 2.0 Flash model. Then we can pass in what tools we want to use. So in this case, what we have is the get availability tool, which looks just like the rest of the availability tools and all the other agents, where we're just going to look to see when is Caitlin free. And we have to do obviously a little bit more because we're trying to get things set up. So we have to like set up like the input for this tool, but you know, just common LangGraph setup. So once we have our tools set up, then what we're going to do is basically set up the system instructions. So this is where we're saying like, hey, you're Caitlin's scheduling assistant, you know, the root instructions. And then finally we could set up response format. So we're like, hey, we need some input, we're completed, we're done. So basically all the different response types. Fantastic. So once we have this graph set up, I do just want to show you the other major important functions for working with LangGraph. It's a little bit more involved, but I still want to show it to you. So when it comes to invoking, this is how we actually kick off our agent to say, hey, go run. And if you're used to LangGraph, everything's pretty much a runnable. So in our case, we're just passing in like, hey, here's when it comes to your configuration, we're going to use the context ID as the thread ID. We're going to pass in a few additional arguments. So we're just going to give it context about what is today. And then we're just going to set up our overall query. So it's going to start off with today's date as some general configuration, and then it's going to pass in the query. Think of this as just like we're passing in, we're building the prompt is basically what we're doing. Finally, what we're going to do next is we are on our graph. So once we have created our graph, we're going to call invoke on it. and just say, hey, here are the messages that I would like you to answer. So in our case, there's really only one message at this point, which is just going to be the root message that we just created. So once we invoke that, it's going to take some time to give us back an answer. And what we can do next is, after it's done running, we can call the get agent response function. So we have a helper function down here, and all it does is it iterates and looks at the graph and basically gets everything that we need to get the response. So what we can do is basically get the state of the graph. So this is where we're going to look up basically the thread ID. And what we're going to do is just basically say like, okay, what happened? Do we need additional input? Were there errors, or did everything complete successfully? If it did complete successfully, I would like to return back this dictionary where it says task completed true, required input false, and also here is the final structured message that you can pass back to the client agent. So that's what we're going to return. And then if for whatever reason, if none of these matched, like we didn't get a structured response, we're just going to say, hey, something went wrong. And that way our host agent can go, hey, Caitlin's agent's just not working. Something's going wrong. Please try again. Okay, cool. So that is the LangGraph agent in a nutshell. And real quick, we do want to support streaming. So if for whatever reason they want to stream a response instead, we're just going to call graph.stream instead of graph.invoke. So this is a good example if you want to check out both approaches. Fantastic. So now we're going to hop over to Agent Executor. And if you remember, the most important function in Agent Executor is execute. So let's look at it. So at this point, you should be able to almost do this in your sleep, to where we're going to make sure we have access to our task ID, context ID, and a message. From there, we're going to work on creating our task updater with our event queue and all the other necessary parameters. Then we're going to submit the work that we're, going to start it. Then we're going to start the work. We're going to take in the raw query. So, hey, Caitlin, are you free tomorrow for pickleball? From there, what we're going to do is, our case, we're going to try to stream the response. So we're not doing invoke. We're going to try out stream, and we're just going to pass in the raw query and the context ID. And from there, it's just going to kick back items in real time. And what we're going to do is pretty much wait for, hey, did this task complete, or did the task require additional user input? And based on these different flags, we're going to handle the updater differently. So if the task is complete, we're going to update the task to working and eventually return back the new agent message. And then what we're going to do is if the agent returned back that, hey, it needs additional user input, we're going to update the task to say, hey, I need more work. And if if the task is not complete, If the task is not complete, we're going to update the status to working. And if it's not either one of these, we know the task is done or an error happened. So what we can do is just update our artifacts where we can say, hey, here's the final message. So part is going to be the final message. And we can say, hey, I'm done. Here's the artifact that I just worked on. Updater complete. This way our client agent knows, hey, this agent's done, work's done. I need to look at the answer. So that is setting up the agent executor in a nutshell. Finally, what we're going to do is one last main.py file to where we have our skills, agent card, and this one is as basic as it can be. One more HTTP request handler where we're working on Caitlin's agent. And then when it comes to our memory store, same thing. In this one, we did do a push notifier just to showcase, because we are streaming. We're going to get back information faster because everything's being streamed. So we did set up, the push notifier. And then finally, we're going to run the server. Okay, so you've now seen each one of these different server agents get set up from end to end. So what we're going to do now is I'm going to actually show you how you can run these agents on your local computer. We're going to look at exactly what's happening in each one of the terminals so you can see what each agent's doing, and I'm going to show you what's happening in ADK. So let's go ahead and run our final demo where we have an ADK agent using the A2A protocol to talk to an ADK agent, a LangGraph agent, and a CrewAI agent. So let's hop over and run this bad boy. So now it's time to run all of our different agents so you can see the A2A protocol in action. So in the root directory, I have, for the A2A friend scheduling, I have a README that's going to walk you through everything that you need to do to set up everything in order to run these projects. The main thing, you need to go grab a Google API key. If you don't have one, definitely just head over to AI Studio and from Google, and you'll be able to generate a key super fast. Okay, so what we want to do now is for each one of the different agents, we want to run them. And the order it's kind of important. You first want to set up all the remote agents, and then finally we're going to run the host agent. The reason we want to do this is because the host agent needs to connect over to all of these separate agents. So here's what you need to do. Per agent that you want to run, you need to CD into the necessary directory. So the Caitlin agent, Carly agent, the Nate agent. You want to CD into each one of those directories. You want to create a virtual environment, activate that virtual environment, and then run the application. So make sure you follow these exact commands in order to run all the different agents. So I've already basically done this. So what you can see right now is I've split up 3 different terminals, Caitlin agent, Carly agent, Nate agent, and I'm going to run each one of those commands you saw a second ago. And the important part is you can see that I have done the activation of the virtual environment. So that's why each one has the name right here. So in this case, I'm going to run the Caitlin agent. This is going to take a second, and boom, everything is spun up. Caitlin agent is running on port, 10,004. We're going to run the Carly agent. The Carly agent should run up on 1002. Fantastic. And then finally, we're going to run the Nate agent, and this one will spin up the CrewAI agent. Take a second. Fantastic. And one other thing I do just want to point out is you're going to notice there's usually a bunch of text at the top. And this is because I've done some print statements as we've generated the calendar to say like, oh, Nate is free on this day at these times. On this other date, he's free on these times. So that's why there's some random print statements, just so you can see the calendars. But yeah, so that is how we spin up the different remote server agents. Now what we can do is head over to our host agent. And the host agent instructions are a little bit different. So in this case, we're going to run ADK web inside of our virtual environment. So now you can see I have my host agent set up right here. So I can just run ADK web, and this will take a second, but it's going to run ADK web on our local machine. Fantastic. So I'm going to open up this window right here where we have a ADK web instance spun up, and you can see the only thing in here is the host agent. So let's run this so you guys can see all of your hard work in action. So first off, let's go ahead and say, what agents are you connected to? So what this should do is say, hey, I'm connected to the Carly agent, Nate agent, and Caitlin agent. Looks clean, looks clean. And what's nice is if you can actually click on any of the events, you can see the host agent has the exact tools we gave it. It has a send message, it has a pickleball court agent, and a list court agent. So it has everything. And the reason it knew these agents right out the gate is because of the root request that we've set up. So you can see the prompt that we built at the very beginning. So let's just hop back through code because I think this is super important for you guys to see. So if you go over to agent for the host, what you can see, if you remember, way down at the bottom, we have this role, core directive, today's date, and available agents. Well, in ADK, if you scroll down all the way to the end, you can see that we have all of this set up here. So you can see right at the bottom for available agents, we have the Carly agent, we have Nate agent, and Caitlin agent. So that we did successfully build out the prompt to load these agents dynamically that we were able to connect to using those remote connections. Great. So now we can say, what time is everyone available tomorrow for pickleball? And what this will do is it should start to send out messages to each one. In this case, it's doing all of these tool calls in parallel. So you can see the first tool call, let's actually come out of this. So the first tool call is going to get sent to the Carly agent. The next one, for some reason, these don't usually update, usually takes a second. This is like an ADK bug, but for whatever reason, sometimes these tool requests don't properly showcase the actual one, like it's a duplicate. But if you actually dive into it, what you can see, the response, so this is an ADK web bug, not our code, but you can see our agents came back and each one of them said, hey, Carly's available at this time. The next agents, like I said, it's kind of an issue that it's not showing in, but the Nate agent would say, I'm available at these times. The Caitlin agents would say, I'm available at these times. So you can see our agent got back everyone's availability for tomorrow. And then you can see, hey, everyone looks like they're available tomorrow at 8 p.m. So now it's going to check to see what courts are available. So this is using a second tool call to where it's making a request to our list courts availabilities. So it's just a regular ADK tool call. And then it's going to say, okay, it looks like everyone's available at 8 p.m. and the court is available tomorrow. Would you like me to book it? And I'm going to say, yes, please book it. And then it's going to then make a tool call to book the pickleball court. And then it's going to say, hey, the court's been booked tomorrow from 8 to 9 under a pickleball game. So yeah, so you can see it did everything. Now, what I want to show you next is what was actually happening over here inside of our agents that we had set up. So let's go, I'm going to expand these so you can see it one at a time. So we're going to look at the Caitlin LangGraph agent first. So you can see right when the server spun up, what happened immediately afterwards is we set up a remote agent connection and it looked up Caitlin's agent card. From there, what it did is we then made a request to Caitlin, which was a post request, which was the send message. So we can do it again. So I can say, what time is Caitlin available today? And what this will do is it'll make another post request here in a second. Yeah, so it's sending the message, boom. So it's another one just sent over to Caitlin, another post request, and then we're gonna get back Caitlin's availability for today. So that's pretty cool, guys. That is our client agent using A2A protocol to talk to a LangGraph agent. Now, same thing for this middle agent right here, which is the Carly agent, which is using ADK. This one, super straightforward. It looks the exact same as the other one. So let's scroll all the way up so you can see right out the gate, we did get Carly's agent card. From there, what we did is we're just logging everything as it's happening. So you can see we're just like, hey, Carly's, here's the prompt that we're running. It does a tool call to get Carly's availability. And then finally, it returns the raw response that, hey, Carly is available on this certain date. Yeah, so this finally gets returned back of Carly's available at this time. And we send it back in a post request, which is going to be a message. Fantastic. And then finally, when it comes to the Nate CrewAI agent, you can see this one looks super cool. It has all the CrewAI outputs and logging. So you can see right out the gate, whenever we ran this server, we instantly got the CrewAI agent card, which told us all the capabilities of this agent. Then we, kicked off the agent because we did CrewAI kickoff and we said, hey, answer the questions about your availability. Are you available today for pickleball? So this was, on June 11th, that was tomorrow. And then it comes back and it runs the crew, it runs the task. Once the task is done thinking, it then returns an answer. And then you can see it's actually thinking through the problem of like, I need to do a tool call. It does the tool call. It gets the output of the tool call. And then finally it returns an answer. Yes, I'm available. Once it has the answer, what it does is it sends back this tool call, or basically the final availability in a message, back to our client. So all around, you can see that these agents are working properly, and you guys have just fully set up a multi-agent scenario to where you have client agents using A2A to talk to remote agents. So all around, this is awesome. I hope you guys, like I said, please steal this example and you can expand from here to use like more real world tools or real world agents. But I think this is the best boilerplate you're going to see when it comes to using all the different major agentic frameworks to use A2A protocol. And just as a quick recap, guys, you are now masters at using the Agent2Agent protocol. You've understand all the core concepts such as agent cards, agent executors. You know how to spin up servers so that other agents can communicate with your agents. So I'm super proud of you guys. And if you had any questions on anything that we talked about today, feel free to drop a question down below or hop over to the Skool Community and access one of the free weekly coaching calls so I can get you unstuck and moving forward on your AI projects. But in the meantime, I definitely recommend checking out all of the other AI content I have right here on my channel. You'll definitely want to check out the ADK crash course. I have a bunch of other full stack AI tutorials here as well. CrewAI content, LangChain content, you name it, I got it. So I definitely recommend checking out whichever video is popping up now on the screen, and I cannot wait to see you guys in the next one. Have a good day. See ya.